Legend has it that man can tip a cow. Today we ask, is it possible or just a myth? Okay, so let's look at the maths behind this. Let's start with some assumptions. We'll assume we know the dimensions of a cow. The cow is modelled as a particle. Air resistance is negligible. We know the force a human can exert, let's say for the average Joe. Here's Joe. The ground is not mountainous or peaty or swampy or in a bog. The cow is not faulty or on performance-enhancing drugs or dead. The cow has an IQ of less than 23, that's an important one. The Riemann hypothesis holds. So here's the cow. 1.8 meters tall, 0.9 meters wide, and it weighs 720 kilograms. And let's push it in this direction, so this is the direction of the force. Then let's construct a lever perpendicular to its force through the cow. The centre of mass is in the centre of this lever. And the distance below it is A, the distance above it is B. A dash of trigonometry, we get that A equals 1 and B equals 1. For the purposes of this problem, we also need the angle the lever makes with the floor. We'll call that x. We're going to need a value for cosine x, which we calculate by 0.9 over 1.8, which is just a half. So here's the equation. It's the mass m times acceleration due to gravity g times cosine x times b, all divided by a plus b. Now we know the mass is 720 kilograms. Acceleration due to gravity is 9.8 meters per second squared. From before, we have cosine x equals a half, and a equals 1 meter, as does b. So by plugging in these values, we get a required force of 1,764 newtons. So let's call it about 1,750 newtons. So, 1,750 newtons to tip a cow, and the average human can only exert 675 newtons. So this means you need about 2.6 people to tip the cow. So Joe here cannot do it.
Aww.
But what if we gave him some friends? Now there are 3 Joes. Between them they can exert 2,025 newtons, which is more than 1,750. So they can tip the cow.
No.